Our next speaker is a designer with a special love for artificial intelligence and unorthodox usage of programming. Currently a senior game designer at 11-bit Studios, working on Frostpunk. Previously involved in free-to-play on every position available. Filled with love to indie scene and game jams. She's a MS with a specialization in experimental biology and an engineer with a specialization in genetic algorithms. Please welcome to the stage Mrs. Marta Fijak. Warm welcome.
Hello. Thank God there's not so many of you, so I'm not so nervous as I'm going to be. But if I'm starting to speak too quickly and you cannot understand, just please throw something at me in my general direction. So we are today going to talk about how coding can improve your daily game design task. It's going to be a specific craftsmanship and filled with a lot of knowledge presentation, so sorry for that because I know that everyone today is really, really tired. But first, few words about me and why it's important in the context of the presentation. Currently, I'm a senior game designer working on Frostpunk at 11-bit Studio, but previously I mostly work on free-to-play titles and did a lot of work on the indie scene. So the use cases I'm going to show you are applicable in those three types of games, so the big games, the indie games, and the free-to-play games. But first, we've got to get something clear. These are examples of a really, really horrific code. It's really bad, I hope you can see something, and we need this light for one special purpose. I want to get rid of all programmers, because everything that's going to happen after that is going to be quite big heresy for them. So please, run if you can. So what we are actually going to talk about. First, why to bother? We have programmers on our teams. Sometimes we have special departments for making tools. So why we need game designers who can program or script and put something together? And then we will go through pitfalls, because if we actually do have those designers, there can be some problems we can go into. Then we will go briefly through the languages and tools we can use as designers and finish it up on the meat of the presentation. So actual use cases and how we did that, why we did that, and how well it occurred. So why to bother? Because it's time effective, actually. If your game designer can code, he can iterate a lot quicker on his systems, on the content, on everything, because if he cannot, there's a lot of things that he has to do manually, which is a mundane and slow task, and then after you do one passage and it took like 3 weeks, you are not going to do another one because it's too time costly. But if he can code, he can make an automation from a lot of those things, and those are those small optimizations that the big tool programmers who are writing the engine and all of other things don't actually have time to do. Also, because of that, it's cost effective. It's a lot cheaper to iterate something on a different prototype in Unity made in a week than have your great grand design put in the main game using the whole team 3 weeks and just at that moment go like, yeah, it sucks. So it can be really cost effective, and also it gives the designers a lot of freedom and makes the communication easier because they know a little bit what programmers do. So the pitfalls, if you actually have that, sorry, are about situations when you have your baby, you have your code, your designer code, a monstrosity of a code that you never should show a programmer because, yeah, it's going to be ugly, but this is fine. And there's that moment when everybody is using it and it's becoming a grander and a grander tool. And there's that moment you have to say stop. You have to get a tools programmer who will take your code, throw it out probably, and write it the proper way. Also, when you are using prototypes, you cannot have 2 games at the same time. You had your design questions, you made a prototype, you got the answer, you iterated, killed the prototype, because you don't want to work on both things in the same time, so keeping the prototype fresh and also making the game. And the third thing is, we are like big children, we just like to play, so there's that problem when you have a new tool, you want to apply it to everything, just to every little thing. I can tell you a time we use a genetic algorithm to balance out something. We could do it on a piece of paper, and it was totally calculatable, but we want to do it this way because it was fun, it was not reasonable. So if you have a mundane task, but you are going to do it only once, and the code you are going to write will take like 2 or 3 days, it's just not worth it, even if it's really, really fun. So, what can we use and what we need from the languages and the tools we as designers going to use? What is important that we have a lot of tools in our hands, all of the design theory, all of the design theory, all of specialistic programs to do that, all of the flowcharts, all of the calculators, all of those things are here to help us become better and make better games. So this is important to remember that coding for us is exactly the same. It's another tool in our toolset. We are not talking about learning to program to become a programmer, because those things are here, so kind of a heresy, because no design patterns, no memory management. It just have to work. So C++ is not the best. If you want to write games, sure, but if you are a designer, this is just a huge overkill. You don't want to care about the memory. If it leaks, no one cares. You don't need to know design patterns, not even complex, just know design patterns, because it can be extremely overwhelming when you are trying to learn to code and see all of those topics you have to went through the algorithm, through the design patterns, through the memory, through a lot of mathematics. But we don't need that. We just need really ugly, small code to work. So we have to have it as high level as possible. We are not going to do any kind of assembler passage to make it a little bit quicker. We don't want to shave 3 milliseconds of the renderer to make the shadows quicker and more beautiful. We don't care. Our code just have to work. And actually, this is the philosophy of content, of memory management that is really useful for the designers. This is the story, if you don't want to read, about the company that was making missiles. And a new engineer came, and he was like, yeah, but your code is leaky. There's a lot of memory leakage. And the thing is, it was by design, because the missile is going to explode at the end, and this is the most efficient way of garbage collection ever created. So no one cares it leaks, and this is the thing we as designers also have to embrace. Our code is like a missile, it's going to explode, but hopefully it will make the thing it should make before it explodes. So let's go through the things we can use and when to use it and how to use it. We'll start with JavaScript. Actually, good, but don't worry, because you can integrate that with Google Spreadsheets, with our fancy calculators and our little content spreadsheets and all of that. We can apply on that JavaScript and make everything more, a lot more. Of course, probably all of us know how to write formulas, even extremely complicated one, but they can be hard to read. Actually, I saw once XML exporter written entirely in formulas. It was a beautiful work, but unneeded, because there was only one person that could understand it. If you put your things in JS, if you go away, someone can look at it, someone will know what it do. Also, because it's the front-end, one of the front-end technologies right now, there's a lot of learning recipes you can use. So, as I told you, robust calculations are on your fingertips. Simulations, I will show you in the use cases what that means and how that can help us balance. And also quick content editors. Because when you are indie, you probably don't have a separate programmer who will write a nice wrap-up for your XML that you write by hand. No, probably not. But if you're a designer who can code, in few lines, you can make your own content editor, which is a lot more nice to use than just writing in Sublime the pure XML. The same thing is, not the same thing, but with really, really similar application, but for the Excel users, is Visual Basic in applications. So again, in Excel, you can do a lot using formulas. But if you enhance your workflow with Visual Basic, you have a lot more things you can do. And actually, here is a little bit more you can do when you switch to MS Access and start using MS SQL. The things you can do with content are remarkable, and I will show you in the use cases. And where to use is exactly the same. It's balance, it's preparing content, mundane content-related tasks, and simulations. Another thing is Python. Again, we work on content. We have the systems, and we fill them with content, and we have to iterate on those. So we don't want to do it by hand. We can do it with Python. Anything that is a text form, it's a JSON, it's XML, it's some kind of a template in Unity metadata. We can take Python, we can do amazing things. And also Python, like all of those, with regular expression are extremely, extremely powerful tool for us to use. And don't be afraid of regular expressions, because if you ever wrote an asterisk in the search bar just to represent any string, you used regular expressions, but regular expressions are a thing on their own, and you can make more specific searches. Okay. And Python is perfect for text editing. And when to use, again, content iterations, and where's text, you can apply it. Oh, and then usual mundane stuff, like you need a list of all monsters in the game. We'll go through it on the use case part. And now time for Unity. Unity is great for prototyping, and I'm not talking about prototyping like on the early stage of development, when everybody is playing, everybody is wanting to do something new, and testing and making small games and killing them. I'm talking about prototyping in a full-fledged production cycle. So, sorry. So we already have a game, we want to add new systems, new huge systems, and this is when Unity comes in handy, because we can test it separately from the game, because not everything you can do on the paper prototype. So yeah, it's good for proof of concepts. And use cases, and how we actually use them in different situations, and what it gave us. So the first problem is the typical content master. We had animators, like a lot of us do, and they were not exactly tidy with the naming conventions of their files, like artists usually are. And we needed a list of actually used animations in the content. So we can throw out all other things from the repository to make it clean, to prepare for releasing the game. So we can have a labor-heavy approach for doing that. We can take a junior and make his next 2 weeks hell. So he will just go through every XML and be like, yeah, that's probably an animation, and that's probably an animation. So Control F through everything, and he will probably die a little bit inside, but the job will be done. But the thing is, we probably will have to do it again and again and again in the production cycle. So we wrote a Python script, and I speak about it like this was so huge task. It was 5 minutes, and it was less than 10 lines of code I'm going to show you in a more abstract way. And this way we saved that guy's pure soul, because he would probably die inside. So what the code do and how designers code look, it's just a small thing. It's a thing that opens the test.xml in that case, and look for everything. This green thing is regular expressions. It looks for everything that finishes with the template, but written with the capital or lower T, it starts with the lower or upper capital T. Of course, the real script was a little bit more robust, because those naming conventions were not good. But this is all that was needed. The probability case. Okay, so this is actually from working on Frostpunk. You know, in that game it's quite cold. So the guy sits in the cold from the first day. He has like few % chances to get cold. Another day it's a little bit higher. Another day it's a little bit higher. And we wanted to know what's the chance of Gary being sick on the day N, summarized from the previous days, to balance it out properly. So the first thing was, yeah, we're smart guys and girls. Let's do it with the mathematical approach. And it was not a good idea, because it was actually done with binomial distribution of Poisson, which is yeah, It's awful. It's really hard to implement, it's really hard to use, and you are not going to be able to write it in a formula in spreadsheet to use every day. So what we did, we once again wrote a JS script, and we did the next best thing to calculating it the proper way, so we just simulated it. We took 10,000 guys, and every day we checked if they got sick or if they didn't got sick. And after that, we have the approximation. The code was really short. It was 50 lines, and it executed in less than a second. So we can use it really comfortably on everyday basis. And this is how it looks. This is all you need to just bypass this monstrosity of a code. And also, you just don't leave things to chance. You know what the chance of getting people sick will be. The next thing is states. It's also done in Frostpunk. As you can imagine, it's a city builder. There are people in that game. And we needed a higher level system to manage the people. I'm not talking AI, I'm talking a system above it to send the info to AI what should they do. So we came up with this ridiculous, huge state machine with calculations, with everything, you know, to put society in mathematics. But the thing is, it was really hard to test. We were looking at that, and we are good all with imaginative play in our heads, but the system was so robust that we couldn't be sure if all of the states that our rule set generates are proper ones, and we want to go with them. So the labor-heavy approach, well, not labor-heavy, but the normal way would be we gave our huge designs to programmers, wait 3 weeks, they put it in Frostpunk, we put some content in it, start playing, and we know it sucks. And then we repeat the cycle. But we wanted to try something new. So we implemented with a really, really awful spaghetti-driven designer code, all of that mess with it into Unity. Using the Unity UI and everything out of the box, we were actually able to do it in less than a week. And for a normal programmer, it would be probably a day. But don't care. And this way, we could iterate it on it without using programmers. The thing was a monstrosity to look at. But we could play it and test it and see if the states that are generated by the rule set are proper or not. So this way, when we actually gave the design to the programmers, it was a lot more refined and a lot more mistakes were catched and changed. Let's get back to Python and killing the souls of our poor juniors. Working on a free-to-play title, there was no content management system. We just wrote in pure XML. So there were enemies in the game. It was a live game. It was a game with thousands of players, 10,000 of players, even more probably. And we have those 200 enemies. And looking on the data, we found out that probably the low HP monsters are too easy, or another, whatever, or another way around, and the high HP are too harsh. And the aggression of the mobs was written in XML in a form of pairs of X and Y, where X was the time and Y was how aggressive the monster is. So what we actually wanted to do, we wanted to check if the monster at hand is higher or lower HP, and then just multiply the Y values, just to check it out. So labor-heavy approach, once again, a soul-crushing experience for another junior designer. Because doing this, taking into account that writing XML will generate errors, and we will have to dig through it would be like 2 weeks of this work. And this is not actually even a problem. The problem is this way, when we did that, we would be like, yeah, this is the better version, or the previous one was the better. We couldn't iterate quickly because every such a change was a really, really labor-intensive thing. And also checking it only on 2 enemies wouldn't be okay, because those aggression charts really varied between them. So what we did, we write a Python script, which did exactly what I told you a few seconds ago. He just took all of the enemies from the XML, it just checked if it's higher or lower HP, and multiplied the Ys. This way, we can do it really, really quickly. We can pass as arguments how much we want to multiply, and just do it over and over and over again, as we found some sweet spot, which was actually beneficial for the game. And the last, I think, use case I'm going to show is the content management. Because working on a similar big free-to-play title, also live, we had a lot of XMLs. Like, I'm talking megabytes of many XMLs with content for the players. And the thing is, no one ever saw why we should have an extra tool. Programmers are good, designers are good on their own, and they're sitting there in those little dark rooms, and they write those XMLs, and it works just fine. Why to change anything? So there wasn't a chance to get a tool programmer for us. So we did the only reasonable thing. We taught ourselves how to code, and we prepared a huge proof of concept in MS Access and Visual Basic applications of a content editor which exported finally those XMLs. And we started to work on it, like actually edited the XMLs using it. And suddenly the managers higher than us saw that we were way more efficient. We were making less mistakes, and we were able to iterate through content more and more and more. And what happened then, after using a few months, this solution, actually they understood that this is a beneficial way for the company, and we've got a real programmer who wrote us a full-fledged tool how we wanted to it. And how to start if you are a designer? Actually, the answer is quite simple. You just have to use the internet. Because we are living in the age that you can find out everything, so you can have those new tools in one weekend. You just have to find the problem you want to solve and reverse engineer it. Just writing in Google how to do something in Python, then you will see that you don't have Python, so you will see how to install Python. And from that moment, you will go and go and go, and finally, there's big profit. And probably it's not going to work the first time, but in the end, it will. And if you don't have such a thing, this is a small bonus, you can start with processing. Processing is a language, it's a Java library, but it's a language specially designed for artists and designers. So it have instant visual feedback, and there's a lot of a community, also those who are jives, which stopped moving, I don't know why. There's a lot of community that can help non-coders to code, just like that. And I hope someone of you is going to try to use those tools. Thank you. Are there any questions?
Hello, thanks for the talk. I wanted to ask you one major question. Why should a game designer waste time on learning a new language for him, really, to deal with this mundane task? Because in this moment, I could be learning about different things, the retention, the engagement of the player, and so on and so on. So why do you think that learning this is more important than the other thing?
I'm not saying that this is more important. Game design is a really interdisciplinary thing. You should expand in all of the directions. But you can have more time to learn for the retention, for the monetization, for the psychology, whatever you want to learn, when you don't have to do those mundane tasks. So this way, spending one weekend, you can get a lot more time to do the things you would like to do. Because probably we are approaching an age that everybody of us is going to have to code a little bit, because it's going to be a disability. So, yeah, this is why.
Thanks.
Any more questions?
Where I can buy such fantastic shoes.
Oh my God. Yeah. My mom told me I shouldn't wear them. Also, my whole company was laughing that this is going to be a final question. Yeah, you can find them in the internet. Yeah.
Any more questions?
So thank you for coming.
Thank you very much.